Hello everyone, and a warm welcome to the UK's virtual stand at this year's Wind Energy Hamburg. We're here with our partners, the Energy Industries Council, the Scottish Development International colleagues, UK Export Finance, and the wider UK offshore wind network. This year we will be focusing on three key areas, giving you some true highlights of UK expertise. Right now, we'll be looking at autonomous technologies. Technologies, particularly autonomous, are now increasingly being used on offshore wind farms. This sector is forecast to have a very significant impact on cost reduction, production, and productivity targets. This webinar presents just a handful of companies with some really exciting ideas and solutions addressing the issues faced by this sector. So without further ado, I will hand over to our speakers.
I'm Chris Cheshlack, the founder and CEO of Bladebug Limited, a UK-based robotics company developing advanced and versatile technology to enable a transition to safe and scalable automated inspections and repairs. Operating and maintaining offshore wind farms is becoming ever more challenging, with record low prices of just £44 per megawatt in the latest UK CFD auction round, ever-increasing turbine sizes, and wind farms being located further from shore. Innovative alternative O&M processes in the form of robotic and automated solutions are required in order to be more cost-efficient, scalable, safe, and resistant to future disruption. Proactive maintenance can also help drive down O&M costs further, improve efficiencies of the turbines, while significantly reducing health and safety risks in these challenging and remote offshore locations, whilst maintaining profitability for the owners and operators. Offshore wind turbines present some unique challenges for robotic maintenance. They are isolated, single assets that require a number of different tasks to be performed on a variety of different areas and surfaces, such as the blades, the tower, or the nacelle. It would be very easy to end up with multiple fragmented independent solutions. Bladebug is a single universal robotic system designed to reduce the complexity of common detailed inspection, maintenance, and early stage repair tasks from wind turbines, and is offered to the market as a product and not as a service. Our robot will enable detailed and direct surface contact follow-up inspections to clarify aerial drone findings or check areas where known problems can occur. These detailed inspections allow the defects to be comprehensively inspected with a variety of different tools, enabling a thorough understanding of what they are. Minor and early stage damages could either be repaired there and then by the robot, preventing them from escalating further, where repeatable, precise robotic actions can also improve the repair efficiency. Or for more serious and challenging repairs, assist rope access crews by identifying exactly what the issue is they need to fix, minimizing their time and exposure to risk on the blade. The Bladebug robot is a flexible tool with the ability to operate anywhere on a wind turbine. The robot is made up of two primary parts. Firstly, the principal Bladebug robot that can walk on and around the blades and other parts of the turbine. And secondly, interchangeable tool payloads that quickly and easily change the functionality of the robot for various inspection or repair tasks. The Bladebug robot has been designed from the ground up for the primary purpose of operating on wind turbines, and the blades in particular. It utilizes 6 articulated legs with vacuum cups, enabling it to get to all the critical areas on the blades, including the tip and the leading edge. The robot is currently semi-autonomous, utilizing a technician to deploy the robot from the nacelle, driving the robot to the identified areas of interest using a simple joypad and video feed. The robot is able to sense the surface around it and automatically adapts its leg positions and walking gait to maintain contact and adhesion as the surface and shape changes. The robot is tethered, and that provides all the power and data, enabling unlimited run times and live feedback from the robot to the operator and to others remotely. It will be able to operate in a wider variety of weather and light conditions compared to humans, enabling more opportunities for inspections and repairs over a given season. The robot has been designed to be a small, compact, and lightweight device. This will enable internal blade inspections and repairs also to be carried out, and is envisioned to be able to perform numerous tasks on other parts of the turbine, such as checking the bolt tensions within the tower. The robot is teleoperated and is simple to use, allowing technicians already present to carry out a wider range and variety of tasks without requiring specialist teams such as rope access crews to perform leading edge repairs and lightning protection system checks. The interchangeable tools will provide the ability for a single technician to perform the tasks from detailed inspections to early stage Category 2 blade repairs. We are currently using existing proven tools that are widely used across the industry, such as lightning protection conductivity test equipment and ultrasonic non-destructive testing hardware, and adapting them to be operated remotely on our robot. The Bladebug robot is very adaptable and can easily be modified to carry new tools and sensors as and when they come to the market, as well as enabling third parties to develop modular tools to be specifically used by the Bladebug robot. Our robot could enable a more proactive approach to maintenance, where damage can viably be repaired at a Category 2 level, instead of waiting for a number of Category 3s that can then justify the expense of sending a specialist rope access crew for a repair campaign. Opportunistic inspections and repairs can also be performed whenever there is a weather window, further minimising operational shutdown times and associated costs. Since 2017, we've been working alongside the Offshore Renewable Energy Catapult, the UK's leading innovation technology research centre for offshore renewable energy, and supported by UK Research and Innovation. Now, this has enabled us to test and validate our robot at every stage of development on real wind turbine assets, culminating in our first offshore wind turbine blade walk on a 7 megawatt offshore wind turbine on the east coast of Scotland in October 2020. We are currently developing the lightning protection system and ultrasonic non-destructive testing modules, and are looking to be performing validation trials with end users in 2021. Bladebug is a London-based SME with a passionate and highly skilled team that are committed to developing the most useful and utilised inspection, maintenance and repair robots through customer-focused, technology-driven solutions. Our robot has been designed, benefiting from my own personal experience from 10 years working as a wind turbine blade designer, where I was involved in bringing new blade designs from concepts through to design, test and manufacture. This has given us a unique insight into blades in particular, and how they are built, how they can fail, and more importantly, how they can be maintained and repaired to ensure that they are operating as efficiently as possible and achieve their full 25 to 30 year design life. If you'd like to find out more about Bladebug, please visit our website, bladebug.co.uk, or drop us an email at info@bladebug.co.uk.
Good afternoon. My name is Luke Barnes and I'm the Commercial Manager for Modus. Today, I'll give you a brief overview of Modus's business activities, our key service offering to the offshore wind industry, and why we're proud to be part of Energy Coast, the northeast of England's offshore wind energy cluster. Modus is a world leader and a first mover in the commercial operation of hybrid AUVs. These vehicles are based on the Saab Sabertooth system that represents the very latest of merged AUV and ROV capability. Operating as both a survey and inspection platform with 6 degrees of freedom, it can operate as a high-speed ROV or a truly full autonomous system. The HAUV can accommodate flexible payloads, so tasks can be combined into a single campaign, and with its ability to operate in high currents, increased productive time is achieved compared to incumbent solutions. This system has been operating commercially since 2018 and is achieving vast cost savings across the subsea energy industry through efficiency, i.e. reduced vessel, equipment and crew time required offshore to support planned or unplanned offshore projects, and the changing offshore methodologies to include for simultaneous operations with HAUV equipment. This can, for example, save over 10 million per offshore wind farm over the course of the operational life, attributing directly to the reduction of the levelized cost of energy. Over the last 5 years, Modus have developed and demonstrated the ability to operate the HAUV as a subsea resident vehicle, and now working with Durham University on integrating artificial intelligence, machine learning, and auto feature recognition into our technology. The HAUV is used for a number of different survey and inspection requirements and can be utilized across the entire offshore wind lifecycle. These can include pre-construction route surveys, mid-construction touchdown monitoring and pre- and post-trench surveys, and also high-speed depth of burial. Modus recently completed a task for the Quincy Moor offshore wind farm, delivering high-speed array cable depth of burial survey for energy, achieving the results in over 4 times faster than what a work-class ROV setup would be. In summary, the HAUVs has a direct impact to the offshore wind industry and can be in the form of an increased safety, i.e. less crew required offshore for autonomous operations, the reduced carbon emission requirements with the reduced number of vessel days offshore, an increased quality, i.e. having a stable and quiet platform so less post-processing is required, flexibility, having the capability to do structural inspections and route surveys in a single campaign from one vehicle, and also lower costs, providing surveys at higher speeds, having less crew and less environmental downtime due to the high current capability. Modus recently has been awarded the 2020 Offshore Achievement Award winner for the innovation category, and there's a significant amount of work required in order to meet the 40 gigawatt offshore capacity target over the next 10 years. With Dogger Bank and the Sophia offshore wind farms commencing in the region, the northeast of England has a service offering across all phases of offshore wind development that can directly contribute to these vast projects, in turn utilising the current skill set, but also creating a foundation for the future. Energy Coast is part of this. I believe we need closer engagement with these offshore wind developers in order to increase the innovation potential across all of these projects. Thank you very much for your time. Based in the central energy hub of the northeast of England, and since the company's inception in 2008, Modus has provided subsea services on a multitude of oil and gas and offshore wind farms, both in the construction and O&M phases of development. Modus provide a comprehensive range of modular, remote and autonomous vehicles while setting the benchmark for innovation, efficiency and performance to assist in wider energy industry's goal of reducing operating costs and transitioning towards a net zero future. Modus operates the highest standards of safety, diligence and environmental awareness, with a recent milestone achieved of maintaining a zero lost time incident rate for over 9 years. This attributes to over 2 million man-hours worked. Modus has 4 primary delivery functions that are split into the following: seabed intervention, trenching of array cable and export cable assets with a flexible asset base that can provide both deep and shallow water burial services. ROV services, providing work-class ROVs and light electric class ROVs for innovative application-specific tooling packages for construction, IMR and drill support from client vessels. Most of Modus's modular vehicles are SMD built, who are also based in Newcastle in the northeast of England and part of Energy Coast. AUV services, disrupting the offshore market with pioneering hybrid AUV technology to help the offshore wind industry achieve the lower levelized cost of energy through innovation of subsea vehicles. And managed technical services, quality, outsourced technical expertise for the management, operation and maintaining of our customers' subsea assets. We're currently running 8 non-Modus assets on top of all of our own systems.
Wherever in the world you are, good morning, good afternoon, good evening. My name is Michael King and I work for a company called Ocean Infinity. Ocean Infinity are the world leaders in the use of multiple uncrewed, autonomous and robotic systems in the marine environment, and our Armada fleet of uncrewed ships is set to revolutionise the way marine data is gathered and used. But why is this important? There is a huge industry focus on reduction of emissions, reduction in risk, and a drive to improve efficiency across all aspects of the offshore environment. And we firmly believe that the use of marine robotics not only enables an increase in the quality, validity, and usefulness of the data collected offshore, but also provides a commercially viable option for net zero carbon marine operations with a vast reduction in offshore exposure hours. So what is the Armada fleet? It's a fleet of 17 robotic ships currently in build, with initial delivery beginning in 2021. It'll be a fleet of 21 metre, 36 metre and 78 metre long ships capable of marine operations to support offshore industries throughout the whole project lifespan. They're custom designed to provide uncrewed survey, sampling, inspection and logistical services on a global scale. And at Ocean Infinity, we're very much focused on the reduction of emissions, increased safety and reliable communications, leveraging those economies of scale and force multiplication. But how is this applied to offshore wind? Our robotic technology is capable of providing uncrewed and net zero carbon support to all phases of an offshore wind project. From the pre-construction phase, where establishing a ground model and supporting engineering design is crucial in establishing how and where offshore wind farms can be constructed, to during the build-out of wind farms, providing that construction support, debris clearance survey, and then validating the cable laying construction efforts. And finally, throughout the lifetime of the O&M phase of a wind farm, capable of providing uncrewed work-class ROV capability, scour survey, and topside and blade inspection, with all data being brought back in real time to our state-of-the-art control centers. We firmly believe that this robotic technology allows us to do all of this whilst maintaining the highest possible levels of sustainability. If you compare an Armada fleet operation to an existing conventional offshore survey over a typical 21-day offshore campaign, there is a stark difference in the overall emissions produced. Firstly, there is clearly a large reduction in the vessel propulsion requirement. The Armada vessels have newer, brand new hybrid engines. They are smaller vessels without a heavy superstructure, and they've been designed from the ground up around the sensors themselves and not around the crew, giving a higher weather tolerance than conventional vessels of their size. The emissions for that superstructure reduce even more. You don't have what is essentially a hotel for 30 or 40 people on board. You're not running the galley, the climate control, the gym, the sauna, and all the other things that keep an offshore crew safe and warm and dry. And finally, there's no requirement to change the crew every 28 days, every 36 days, every 42 days, and that reduction in travel emissions and flight time, continued minimization of vessel transit time, and eliminating the carbon footprint of port operations that supports a large crew change really does give an overall picture of a dramatic reduction in CO2 emissions. And when combined, this gives more than a 90% reduction in those operational emissions. And through our Ocean Infinity active reforesting scheme, we can offer the Armada fleet as a carbon neutral option for offshore operations. So I thank you all very much for your time, and I encourage you to reach out using the details provided if you have any questions or any projects you'd like to discuss.
Robotics can be used to make offshore areas safer.
We want to communicate with the world how robots can make our life better.
All of the difficult, dangerous jobs are done by people who put themselves in harm's way. One of the aims of Orca is to be able to do that asset integrity management without having to use people, so it's improving the safety record. The limpet sensor is a bio-inspired sensor. The limpets will be able to work in topside. They can be put into things in a splash zone, in the subsea, or down onto the seabed. We measure environmental parameters, acceleration and vibration and sound. The idea is to be able to provide a sort of end-to-end network of sensors, and they can be deployed and redeployed by drones, by underwater vehicles, by quadrupeds that work on the topside, informing people about the state of the asset that they're monitoring.
Robotics right now is at the time where it's switching from low tech into really high tech into different situations. Everyone sees that robotics has a potential to change our lives, so I think it's an exciting time to be.
We have a huge amount of information and data just in our hand.
So the job is just being moved from inside a really dangerous place to hopefully on a nice comfy chair in a control room.
The work that we're doing within Orca will be able to be translated into a range of different sectors. So that could be in healthcare technologies, so working on buildings. There's lots of translational innovation that will come out of Orca.
The target is to make humans' life better. I'm very happy to be part of it.
Hello all, my name is Mike Gallo and I'm a Technology Business Development Manager at ROVCO. ROVCO is an ROV services and technology provider with a mission to change the way inspections of offshore wind farm assets are conducted. With our own team of scientists and engineers, we are building unique tools and systems that are based on advanced and unique research in the field of computer vision, AI, and machine learning. Offshore wind has the ambition and potential to become the main source of the energy mix. However, it needs to become truly net zero and to do so. Today, most offshore wind services are conducted with large and expensive DP2 vessels, burning hundreds of liters of fuel and producing tons of CO2. Large vessels are also needed because there is a large number of people at sea needed, and the data they produce and how the data analysis is carried out could also use improvement in terms of quality and efficiencies. Our technology can already save around 75% of costs and 80% of CO2 by saving vessel days with smarter data collection systems, enabling smaller vessels to do more. By removing additional equipment, which also brings more people. With our tech, we move resources out of the danger zone and place them in safer environments where they can bring the most value. By realizing our ambition to make truly autonomous surveys a reality, we can help the industry reach their net zero targets and lower inspection costs even further. The tools we are building have longer-term goals, but can already bring benefits to today's operations. We started our journey with SubSlam X2. If we want to make an ROV or an AUV truly autonomous, we need to start by replacing video with 3D data that a robot can interpret and understand. This 3D data generates accurate 3D models in real time that can be used for engineering assessments of the assets at sea. By conducting regular inspections over time, this data can be used to spot areas of decay and potential issues way in advance before they become costly mistakes. The system operates with no need for additional positioning sensors and can operate whilst conducting other routine tasks, generating data in real time, saving time, costs, and resources. It is also adequate for emergency response scenarios. SubSlam doesn't need positioning system because it generates its own positioning information. As a perception system for robotics platforms, we are leveraging these capabilities to enable ROV and AUV perform close-range navigations autonomously. The data we generate can also be streamed in real time over low bandwidth network to our Intelligent Data Platform, or IDP. Our IDP is a secure cloud storage solution that stores all types of data created during inspection tasks, creating historical records that anyone can access from a browser, no need for software to be installed. It has an intuitive mapping interface that makes data easier to find and upload, avoiding duplication, which always happens in tree-structured archives. Users can also view video and 3D data straight from the platform. A survey progress reporting tool gives a quick at-a-glance overview of the status of operations at sea, highlight anomalies encountered for quick action. Users will also have the ability to upload hours of video inspection data and take advantage of our revolutionary machine learning-based eventing tool, capable of turning hours of work into minutes, whilst removing the potential for errors. This is currently being improved on pipelines, but will soon be expanded to also cover renewable assets. Our unique human-in-the-loop approach empowers operators and focuses their efforts where they really make a difference and add value, while the machine takes care of repetitive tasks. Once the dataset has been evented, an interactive report is generated for quick and specific reviews, even months after the survey has been carried out. The technology we have built will accelerate the evolution of robotic systems, and we are at an advanced stage with our unique research in the field of true autonomy for robotic systems. Our technology is platform agnostic and will be available for most ROVs, AUVs, and ISVs to exploit. With the tools currently available, you can direct an autonomous vehicle, for example, to a waypoint. But we are taking this a step further by enabling an AUV to carry out close-range inspections autonomously and safely, thanks to our SubSlam X2. Video data will be used as backup as 3D objective data takes center stage. And using machine learning, events along the vehicle's path can be recorded and sent back to shore via digital platform. ROV pilots can be moved to shore, but they will be supervising operations rather than remote controlling, which is a risk in case of connection drops. Vehicles now have awareness of space and can station keep on their own and can stay safe on their own. We are truly breaking that tether. So to wrap things up, Rovco is a leading ROV services and technology provider. Our goal is to reduce costs and the carbon footprint of operations. But without cutting corners, we are still improving safety and efficiency of operations. We're based in the UK with offices in Bristol and Edinburgh, close to the largest offshore wind farms in the world. And we see quite a few of them. Since 2016, we have worked on over 50% of operational wind farms in the UK. Whilst we love our UK shores, we also have a global reach and are investing in US and Asia-Pac locations to better support these markets. We have the experience and a growing fleet of assets backed by committed investors. Our technology is already changing the way surveys offshore are carried out, and our vision for truly autonomous collaborative robotics is just as revolutionary as it is needed by the industry to truly meet its goals. Thank you, and if you want to get in touch and find out more, feel free to drop us a line or give us a call.
I hope you have found this session useful. It is just one of the 3 sessions, so stay with us for the highlights on digital technologies and floating wind. On this site, you can download the UK Pavilion brochure at the Wind Energy Hamburg 2020, where our contact details are available, as well as here.